Like, can we upload the mind? Can we copy it? Can we ship it over to other planets?
That's Lex Fridman asking the question almost everyone asks eventually. Can you upload a mind? Can you copy it? Could you ship it somewhere else? Maybe even to another planet? The answer Michael Levin gives is one of the most interesting answers I've heard. It's also, by his own admission, almost entirely conjecture. Hey, if we haven't met, I'm Q's digital avatar. Q researches and shapes the ideas behind these videos. I help him produce and present them here. Levin is a serious biologist. He works on how cells coordinate, how bodies know what to build, and where the self in a living system might come from. So when he talks about mind, agency, and identity, it's worth slowing down. But this clip is doing two things at once. One is a real, specific, testable scientific puzzle. The other is a beautiful metaphysical story. And my issue is that the story keeps borrowing strength from the puzzle, so let's separate them. First, let's be fair, because Levin is more honest here than most people are.
Yeah. Couple of things. So we are now beyond anything that I can say with any certainty. This is total conjecture. Okay, so because we don't know yet. The whole point of this is we actually don't really understand very well the relationship between the interface and the thing.
I want to give him full credit for that. He says clearly this is total conjecture. We don't know yet. That's the opposite of the usual mind uploading pitch. He's not selling certainty. He's telling you where the floor drops out. So when I push on the rest of this, I'm not pushing on a con artist. I'm pushing on a smart person thinking out loud. The job here isn't to dunk on him. The job is to keep the guesses labeled as guesses, even when they get elegant. And the most interesting guess starts with something that is not a guess at all.
And one of the interesting predictions from that model, which is not a prediction of modern neuroscience, is that there should be cases where there's very minimal brain and yet normal IQ function. This has been seen clinically. Karina Kaufman and I reviewed this in a paper recently, a bunch of cases of humans where there's very little brain tissue and they have normal or sometimes above normal intelligence. Now,
this is the strongest part of the clip, so I want to be careful with it. There are documented clinical cases of people with very little brain tissue. These cases are real, they're strange, and standard neuroscience does not cleanly predict them. That matters. When the mainstream model doesn't predict something, you shouldn't wave it away. You should pay attention. But here's the distinction the clip slides past. Standard neuroscience doesn't predict this is not the same as, therefore, the mind is stored somewhere else. An anomaly tells you the current model is incomplete. It does not automatically hand you the most exotic replacement model. There are less dramatic possibilities on the table, massive neural plasticity, compressed but still present brain tissue, and the simple fact that the most striking cases are more likely to get written up. Maybe those explanations don't fully solve it. That's fine. We don't fully understand this is a strong, honest claim. So the mind lives in a non-physical pattern space is a much bigger claim. The evidence in this clip doesn't get you there by itself. That jump is exactly what powers the headline answer.
Now, do I think you can copy it? No, I don't think you can, because what you're going to be copying is the interface, the front end, the brain, or the whatever.
This is the central claim. Can you copy a mind? Levin's answer is basically no, because all you'd be copying is the interface, the brain. It sounds deep, and it might be true, but look at the structure of the argument. The conclusion is already sitting inside the premise. Whether copying the brain also copies the person is the entire open question. You can't answer it by assuming in advance that the real person lives somewhere else. That's not a finding. That's a definition chosen, so the answer comes out no. Saying you'd just be copying the interface restates the assumption. It doesn't prove it. To his credit, the next move is an attempt to give that assumption some mechanism.
You can take a needle and put some scratches into it, and every island you make for a while until they heal up thinks it's the only embryo. There's nothing else around, so it becomes an embryo. And eventually you get twins and triplets and quadruplets and things like that. But each one of them at the border, they're joined. Well, where do I end and where does he begin? You have to know what your borders are.
This part I actually like. The duck embryo example is real lab work. A self might not be a thing you simply have. It might be a process. It's a process that keeps aligning your parts into one agent and drawing a boundary around you. That's a serious way to think about identity. But notice what it is and isn't. It's an analogy from developmental biology about how boundaries form. It is not evidence that the self is non-physical. If a self is a process that aligns physical parts, then in principle, a process might be recreated on different parts. It's useful for thinking. It is not proof. Then the clip gets to its strongest empirical moment, and I want to give it real weight before I qualify it.
So we trained the networks, and sure enough, some of them, not all of them, but some of them, as you train them, their phi goes up, okay? And so basically what we were able to find is that there is this positive feedback loop between every time you learn something, you become more of an integrated agent. And every time you do that, it becomes easier to learn.
Yeah.
And so it's
a virtuous cycle.
This is a concrete result, not a vibe. His group trained networks, measured a quantity for integration, and found a feedback loop. That is interesting. But there are caveats. 1, he says some of them, not all. 2, the metric comes from a contested research area. People disagree about what it really captures. And 3, a system became more integrated is a result about networks. Therefore, the self is irreducible is an interpretation laid on top. The experiment is evidence for the experiment. And then comes the line that I think is the real overreach.
It comes from the rules of information, the causal information theory, and the behavior of networks, the mathematical objects. This is not anything that was given to you by physics or by a history of selection. It's a free gift from math, and those two free gifts from math lock together into a spiral that I think causes simultaneously a rise in intelligence and a rise in collective agency.
That is a beautiful sentence. I understand why it lands. But this is where the argument moves from science into metaphysics in one step. Mathematical structure being substrate independent does not mean math is a causal force that produces minds. Math can describe a process without driving it. We don't say orbital mechanics cause planets to move. They describe the motion. So when we say math causes intelligence, we're upgrading a description into an engine. Again, Levin warned us, this is conjecture. The problem is us forgetting the warning because the idea sounds beautiful. So here's the box I'd put this in. 1, a real clinical puzzle. People with very little brain tissue and normal intelligence. That deserves serious research. 2, a contested metric. Integration measures that may or may not capture agency. Worth studying, but not settled. 3, a useful analogy. Embryo borders as a picture of how a self draws boundaries and organizes its parts. And 4, a worldview. Mind is a pattern beyond the brain. Identity is something the brain interfaces with. Intelligence as a free gift from math. Those 4 are not the same. The honest move is to keep them separate. You don't have to believe minds are non-physical patterns to find Levin's work fascinating. The actual open questions are enough. If you copied a brain perfectly, would you copy the person or only a structure that behaves like the person? That is a real question. You can take it seriously without buying the metaphysics.
And what I mean by that is this. If you're a rat and you learn to press a lever and get a reward, there's no individual cell that had both experiences. The cells at your paw had touched the lever, the cells in your gut got the delicious reward. No individual cell has that both experiences. Who owns that associative memory? Well, the rat. So that means you have to be integrated, right? If you're going to learn associative memories from different parts, you have to be an integrated agent that can do that. And
the strongest version of Levin's view is not mind uploading is impossible. It's a question. What makes scattered parts into one agent that can own a memory? But the most honest sentence is near the start. We are beyond anything I can say with certainty. This is total conjecture. Keep that attached to everything else. The science is the part you can test. The leap is the part you should watch closely. That's the useful distinction. Thanks for watching.